Hello students. So we are going to discuss about the typical architecture of an embedded system, and with this topic we will also cover the another thing, which is quality attributes of embedded system. Okay, so this is a very basic architecture of an embedded system. Here you can see there is an input. The total block is known as embedded system. There is a software. The software is application specific software, and it is there are embedded operating system, and in the hardware case you have embedded microcontroller or microprocessor, and there are some peripheral devices also in the hardware, and when we get some input, some specific output we get at the output. Okay, so thus all the theory about this type of embedded system is available over there. So let's read it, and in this you can find that a figure shows a configuration diagram of a typical embedded system consisting of two main parts: embedded system hardware and embedded software. So the embedded hardware primarily includes the processor, memory bus, peripheral devices, input output ports, and various controllers. So the embedded software usually contains the embedded operating system and various applications. So definitely we have the embedded operating system or application specific software, which are very small. These are of some of few lines to some hundreds of lines software, which is available for the particular microcontroller or particular embedded system. Input and output characteristics of any embedded systems, and the embedded system is no exception. In the embedded system, the hardware and software often collaborated to deal with the various input signals from the outside and outputs of the processing results through some form. So output may be some your physical form, in some physical form, or some useful measurable output. The input signal may be ergonomic device such as keyboard, mouse, or touch screen. So such type of input may available. So whenever there is an input for the embedded system, so inputs are very simple. For example, the touch button, a simple push button. So such type of buttons are available for the input. The output may be in the form of the sound, light, electricity, and another analog or recordable file for the database. So that is a typical architecture of an embedded system. So typical hardware architecture of embedded systems are over there. So the basic computer systems components, microprocessor, memory, and input-output modules are interconnected by a system bus for all types of for all the parts of them communicate with a executable program. So for such case we have microcontroller or microprocessor with some registers, unit with some execution. You are the students of electronics. You may know about the 8085 microcontroller, which has some registers, one execution unit were also over there, some system bus were there. So one memory is there which has some instruction and data, some input output modules are over there, and which is for example GPIOs. So UART or Q registers, stack registers. So all these things are available in a typical hardware unit. So basically we can divide the hardware into two types. One is your von Neumann architecture, and another is your Harvard architecture. So these two types of architectures are available in the market. So in the von Neumann architecture we have a memory, and all the code and the data are available on a single memory. So we have to deal with this memory one by one. First instruction fetches, and then data fetches, and then some input and output after manipulation on the data happens. Okay, so the data is also stored in some memory. So that is this architecture of the von Neumann. In this case, your code and data memory is in the same memory, while in Harvard architecture you have different instruction and data memory. So you have program memory, you have data memory. Both are separate, and separately you deal with the instructions and the data. So from one end you capture the data, and another end you capture the data. From one end you capture the instruction, and another end you can capture the data. So if I talk about a clock cycle, so in a single clock cycle you will retrieve a single instruction, then in the next clock cycle you will get the data, while in this case in a single clock cycle you can get both the instruction as well as the data, right? So definitely Harvard architecture is more faster than that of the von Neumann architecture. Okay, so this is all about the typical hardware architectures of the embedded system. Now let's discuss about the quality attributes of the embedded system. So there are two types of the quality attributes. One is operational quality attributes and non-operational quality attributes. So these are attributes that relate to the operation or functioning of an embedded system, and the way an embedded system operates affects its overall quality. Non-operational quality system, there are attributes not related to the operational or functional attributes. The way of the functional does not affects its overall quality. So these are the attributes that are associated with embedded system before it can be put in a operation. Okay, so operational attributes. Response is a measure of the quickness of the system. It gives you an idea about how fast your system is tracking the input variables. Most of the embedded system demands a fast response, which should be real time. Throughput. So throughput deals with these all are the quality attributes of the embedded system. So throughput deals with the efficiency of the system. It can be defined as rate of production or process of a defined process over a stated period of time. Sorry for this dot. In case of the card reader, like the ones used in buses, throughput means how much transaction the reader can perform in a minute or an hour. So it is per unit of time. It may be minute, it may be hour, it may be day. Reliability is a measure of how much percentage you rely upon the proper functioning of the system. Okay, so the mean time between failures and the mean time to repair, the terms used in the defining the system reliability. So you should cramp all these things. So this is about the quality attributes of the system. So next slides belongs to some important concepts which are related to not related to with your syllabus, but related with your knowledge as you are the students of electronics. You should know about this. So there is a time to market or demanding design metrics. So time is required to develop a product to the point it can be sold to a customer. It is a time to market. And market window. So this is a market window, basically period during which the product would have highest sales. Average time to market constraints, it's about 8 months. Delays can be costly. On-time entry and delayed time entry. So on-time entry, if we provide an on-time entry in a market, then a peak revenue can be made, and if we delayed in a market, then there will be a delay, and there will be market fall will start, and then we cannot achieve a very good peak from this point of view. So we can have a good revenue when we use it, when we started on time. If we delayed the system, then there is peak revenue, delayed entry will be over there. Dependability. So reliability probability of a system working correctly, provided that it worked at a time t equal to 0. Maintainability, probability of a system working correctly the time units after error occurred. Okay, so these are all the design constraints. So some real-time considerations are also there. So 3 types of real-time possibilities may possible: some hard real-time, firm real-time, and soft real-time, that you can understand by this diagram. In hard real-time, tasks must come before the time interval, and in firm real-time, the firm deadline you should if output should come at a t equal to 0, then it must come at t equal to 0, not t minus 0, not a t plus 0. And soft real time, the task should complete within this amount of time, which is falling rate of the time. So that is all about the hard real time, soft real time. So it is about embedded processor. So there is a power, performance and programmability and flexibility of embedded systems. So this is embedded application specific processor, which are specialized processors. Then embedded domain specific processors, which are graphical processor, DSP for network processor. Some general purpose processor, for example your personal computer. Okay, so these all things I have enrolled these things for your knowledge only, so you can find these things, and if you have any problem in these things, you can talk to me. In spite of this, I want to talk to you with your syllabus. So here is your syllabus. So I have covered all the things in the unit 1. So your unit 1 has been completed. I have covered the embedded system versus general purpose computing, history of embedded system, classification of embedded system, application areas of embedded system, typical embedded system, characteristics and quality attributes of the embedded system. So I have already covered all these topics. So your unit 1 has been completed. So thank you for this lecture. Thank you.